Guys, welcome back to our channel. Today we will see NXCAM tutorial, cavity milling, roughing, diameter 20 mm end mill and 1 mm allowance in both side and floor. Rest milling, semi-finishing, diameter 14 mm end mill and 0.5 mm allowance in both side and floor. Rest milling finishing, diameter 10 mm end mill and no allowance in both side and floor. Also explain how to do trim boundaries and how to change level first, depth first options.
This exercise we will do cavity milling roughing followed by rest milling semi finishing and finally we will do rest milling by finishing operations. In this case we will take different diameter of the cutters and we will give allowances on each and every operations. For example, in roughing we will give 1 mm allowance for sewing only, then semi finishing 0.5 mm allowance, then finishing there will be no allowances. We have to do or we have to create one model. Go to sketch command. Okay, we will create one workpiece by using this option. The width is 100 mm and the height is 200 mm. Then I will make radius of 40 and rotation 0. Here I will put radius 40, angle is 0. We will close it. Then we will go for circular command. We will put x0 and y 70. The diameter I am putting 40. Then we will go for rectangular command. Here I am going to create one rectangular command. X value 0 and y value 70. The width of the rectangular is 40 and height is so 40 and is 0. Now I will finish my sketch. I will extrude. Minus 20 mm. I am going to extrude. Then I will cut this rectangular, hexagonal and round with using extrude options. Subtract options. Specify depth. I will save this model. Right now there is no need of this sketch. I will go to sketch command and made it hide. Here I have to make flat card radius. Go to edge blend. This. Here also hexagonal. I am going to put and corner radius I am going to put 5. Now I will do this rectangular packet operations, hexagonal packet operations, circular options. First I am going to explain in cavity milling. In this cavity milling I am giving allowance 1 mm both side as well as in floor. Go to applications, go to manufacturing, go to CAM session configuration, CAM general, and go to mill contour. MCS mill CAM. MCS means machine coordinate system under the geometry of mill. We have to go and edit. We have to specify MCS machine coordinate system. Here I am putting here 00. Where the UCS came, I also put that MCS for reference, easy reference purpose. And save clearance plane means the cutter will come 10 mm above the workpiece. Next one is workpiece. I have to go. I have to specify my part. This is my part. And specify my blank. Go to bounding block. Put all everything x plus y plus z plus or minus all are in 0. So my workpiece is as a blank material. My material, go to library. We are having n number of materials available for carbon steel, alloy steel, stainless steel. I am going to take 1116 grade of carbon steel. It gives hardness of 150 to 200. For reference purpose, you can write down high speed steel. Sorry. This is mild steel. We go to enter. Now we have completed MCS mill and workpiece. Now we will go for create operations. In this operation, first we will go for cavity mill. Program already there. Geometry, MCS, none and workpiece. We go to set workpiece, and here we will go for roughing operations. See, part is specified. Blank is also specified. We have to show or specify cut area. This is my cut area. I have selected in this way, or you can select individual surface also. Next one is tool, tooling option. Create new tools. You can go for pen mill, where you can write down that pen mill, dia 20 mm or 20 mm for your reference. You can write down here. You have to put 20 mm, and the length of the cutter is 75 mm, and flute length is having 50 mm. Here you can put it your material HSS. First we have taken 20 mm mill. You can put tool number 1 for creating G code in for CNC milling. Now we will take it mill drop method, and I already explained in introduction. We will give 1 mm allowance both side and floor. We have to go edit, and we have already it is there. Otherwise you have to enter 1.0, and here also you can cutting parameters also you have to check it. Start, and it is having use flow same as side. means this 1 mm is for both side as well as floor. The cut pattern method is, there are so many methods available: follow path or follow periphery or profile. I can select, you can select it anything as you like. I am considering follow path and I will explain each and every steps. That step over means tool flat, 50% means 10 mm it will move after completion of one cut. With crosswise or transverse 10 mm it will move. My depth of cut is 1 mm. Here we can see the depth range is 5 mm and depth of cut is 1 mm for showing purpose. Then cutting parameters, you can staging, you can go for up milling or down milling. It is down milling, it is up milling. As per your need, you can change it. Next one is non-cutting moves. Here, how to engage the tool. We can go for helical or go for ramp or go for plunge. Better you can take it helical or ramp and say for industrial use. If you are putting plunge, it will directly hit on the workpiece. The chance may be broken up cutter or getting vibrations when it enters first. So better go for helical or ramp and say. Then retract, how the tool engage, the same it will retract back. After completion of machining, it will go back 10 mm above the workpiece. But feeds and feeds, it is very important. We are taking workpiece material carbon steel or mild steel and my tool material is SSS. In this case, normally the surface feed of a material is 25 to 30 meter per minute. I can consider maximum meter per minute 30. I can go for calculate feeds and feeds. The feed per tooth is automatically calculated 0.26. If it is in roughing, we can take it. If we are going to finish it, we can go for 0.08 or 0.1. The cutter 477 RPM. You can change it as per required. 500 make it and go to optimize feed rate. Now we have to check it. We have selected workpiece, specify part, specify blank, specify cut area. We have selected tool and cut method is rough. Cut pattern is follow part. Step over tool flat. Depth of cut is 1 mm and we will check it. We will go for generate the programs. Now we will verify my bar. Make it slow. It will be visible. So this 1 mm material I have given allowances, both side and floor. On floor also it will not take material. It will go up to 4 mm depth. Remaining 1 mm material will be there for future machining operations. See, 1, 2, 3, 4. 4 mm it gets gone. 1 mm material is there remaining. We can also check it. Carefully see. Now it is showing. So this is one method is level first method. Another one method is depth first method. Now it is doing level first, means each and every time it will take cut parallelly. This 1 mm, then it will go to hexagonal and take 1 mm, and it will go to square packet, take 1 mm. Then again it will go 2 mm, 2 mm, 2 mm. Means each and every time the depth will be constant and it will using level based methods. If you are using depth based, first it will complete all circular packet first, then it will go to hexagonal and complete the hexagonal packet, and third it will go to square and complete the packets. Where we can change it, you can go edit, go to cutting parameters. Here we can change it depth first. We have to verify. See, now it is completed first packet, circular packet. After completion only it will go to hexagonal, and after completing hexagonal it will go to square. Means this is called depth first. Okay, now we will go for rest milling operations. Here this rest milling is there. Program tool, we have to select it. Workpiece we can put for finishing. Rest milling is there. You can also give name rest milling. You can give rest milling semi finish. As reference you can type it. Here you have to select cut area. We have selected cut area. We go to select the tool. Here we will go for mill. We will take it 14 mm end mill. Okay. Here we have to write down that 14 mm end mill. The length might be having 50 mm length. The float length may be having 30 mm. Now this the tool number is 2. Second tool, if you are creating number 1, 2, it will be easy for converting this program into G code imports. Mill semi finish method. Here 0.25 default is there. Already I explained that I am going to give 0.5 mm material. We will give for allowances for finishing operations. Follow part, tool part, everything I have not changed anything. That depth of cut, here I am going to give 0.5 mm. Then cutting parameters I have not. Here you can see that 0.5 allowances board, floor and side. Then non-cutting moves is same. Here we have to go for feeds and speeds. Material same. Workpiece material is mild steel. Tool material successes. Here also we have to put 30. Get calculation. The feed per tooth is 0.18. The spindle should rotate 682 RPM, revolution per minute. We have to click for optimize speed for. Then we will go for generate the programs. Save it. Toolbar. Verify. We'll make it very slow. Here, see, each and every time it is taking. This using by level based method. We can change it as per your requirements. Now I will change it. It is removing the material of 0.5 mm. We have given 1 mm allowance. In this semi finishing by using rest milling, I have given 0.5 allowance for finishing purpose. So it is taking that 0.5 material only. You can go a little bit fast. Here the bottom, it will take 0.5 material, remaining 0.5 material is there for finishing operations. Then go for rest milling semi-finish. Either you can copy or you can create. You can copy it better, copy and go to paste it, and you can change the name. Finishing. Here we will edit it. Part is same, blank is same, cut area is same. Here we have to change the cutter, new cutters, mill 10 mm. We will take N mill 10 mm. Here 10 mm N mill. The tool number you have to give for 3. Okay. Then we will go for finishing option. We have to check it. Is there any allowances? We have already this defaulted 00 means we are not giving any allowance. Here the depth of cut you can give it 0.5 or 0.2 as per your requirement, or 0.25 depth of cut. Cutting parameters are same. Now you can check it in this stuff. It is 0. And finally we will check it feeds and feeds. Here we have to enter means if you go for 30 or 35. Here I will write down that maybe might be 30. Here if you are calculating, already calculated there 0.13. If it is in finishing you can change it 0.08. That RPM is 955 revolution per minute. Means this diameter N mill 10 mm N mill, it will rotate 955 RPM. We have to put it. We have to generate the third one programs. Okay. Then we will save that programs. Now here you can also change by go to cutting parameters. Here steady you can go for depth first. Means first it will come circular, then hexagonal, then square. Then we will go for third operations. See, now it will complete all materials. There will be no allowances. Again it will go to bottom also, and it will remove remaining 0.5 material. Next it is going to hexagonal packets. In semi finishing, that time we have given 0.5 material both side and floor. Now side has been taken. Now it will go to floor and it will take 0.5 material, remaining material here. This 0.5 material. The white surface visible means there is no material. Now it is taking up to 5 mm material total depth. So there is no material remaining in this workpiece. Now we will go and check it by using analyzing whether is there any material available, or you can go for analyzing. See, this navy blue comes with 0.000 means all material has been machined. There is no material or there is no allowances material which we have given is not there, means completely machined as per industry norms, means we have completed as per standard. We will close it. Next, the standard process is go into post processor, go to 3 axis, or you can take it any one post processor as you like. Here cinematic post processor there, it is IN means inch, 840D mm means metric. We can take it any one. I have taken mill 3 axis. This is output file where you want to put this file. The most important point is that post processor you have to convert whether in inch or metric. If you require mm, you have to select metric part. Then go to OK. Now the post process has converted into G code M code program for CNC milling. This is by defaultly I am getting Fanuc program. In this way you can convert that process to CNC milling Fanuc programs. If you want to go for head and end, it will give the reading of head and end. If you will go for cinematic, it will give the reading of cinematics. Again, I am going to explain G40 cutter radius compensation nil, G17 plane, XY and Z is vertical plane, G90 absolute coordinate system, G71 the readings are coming in metric means mm, G91 incremental coordinate system, G28 reference, T03 tool number 3, M06 spindle change, tool change automatically, G43 cutter radius, cutter tool length compensation, Z 10 mm. We already given safe clearance in 10 mm, means the cutter will come 10 mm above. Then it will going to take the material. It is converting all 3 post processor. We have to check it. After completion of workpiece, again the cutter will go back 10 mm over 0. Now you can also add or edit it. Either we can go for N 0 2 0 0 M30 program end, or we can change it here also M30. We can save it. We can give number, any name or number. I am giving this folder. In this folder I have defaulted to place it. Now next step is that we go to simulate machine, and we can see by simulation options. In these options we have to go for machine tool view. We have to select generic machines, go to edit. Here you have to retrieve machine from library. There are lot of machines available. If you are milling programming milling machine, you have to select it mill. Go to OK. Then in your software you may Fanuc control or head and end or cinematic. If you are having Fanuc control, you can click it Fanuc control. Okay. The next one is we discussing how we are going to do this workpiece on machine table. I am telling that this is the bottommost portion. I will keep machine table. See the workpiece is clamp. Now we will simulate that machines by using simulate machine options. Here material removal that is there. We will go for slowly initially, then after that we will go for fast. See, the material is removed. In this way you can simulate your workpiece by using machines. Now it is using level first method, so each and every time it will take 1 mm depth First in circular, second hexagonal, third one is in square packets. If you will put depth first, completely it will do circular packet first, then it will go for hexagonal, and third it will go for square packets. Little bit fast I made it. Now the second cutter is coming.
Now hush, little baby, don't.
Now we can increase that one. Now increase the speed. Now we will go and see that. Now third cutter will come and it will completely remove remaining materials. See? Now it will also go to bottom and it will take remaining fine pay material which previous operation was left. See? It is using depth first method. Finally, it will cut circular packet methods. Close. We will remove that machines. We will save it. Now, final step is go to documentation purpose. We go to documented each and every material. Here you see in cavity milling is there, in mill dia. It will take 4.87 minutes. Second dust milling operations, it will take 11.44 minutes. Then final finishing, dust milling finishing operations, in mill dia is 10 mm. It take 48.62 minutes. In this way, you can keep this program sheet as a reference and make it reference for your future purpose. The next command is how to trim boundaries. Go to top view, take it applications, modeling view, sketch. You can select this is my sketch. Take rectangular comments by using 2 points method. Here, this is your midpoint. This half of the portions, this portion, this portion, this portions, we can trim it. This sketch, go for isometric view. This half of the portions we can trim it, and the remaining portion we can take machining. Go to applications, go to manufacturing. Here already we have created cavity mill. In this case also we can save or we can remove this trim boundaries. I will delete it. This I will go for edit. Here trim boundaries are there. We go to selecting. Go to curves method. 1, 2, 3, 4 means side trim. You have trimming in this side, so the machining will take place in these surfaces, in these sides only. Okay. You can check it part blank, cut area, trimming boundary, and tool. You can take some new tools. If you are interested, you can go for 5 mm. For showing purpose, here you can write on 5 mm tool number 1 and go to finishing methods and you can check it. There is no material allowance here given. Tool plot 50. You can go for 0.5 or 0.2, 0.1 mm as per requirement. That is not important. The important is that how to specify trim. Cut levels, cutting parameters same, non-cutting moves are same, fits and fits are same. We have to go for generate that. See, this is my trim area. That opposite side the material will take place. Slow. In this case, we can save it. So clearly. Normally, in industry, we are not using trim for this type of material. For sewing purpose only, or how you go to trim, for that purpose only, I am taking this trimming options. Normal trimming option is different applications in different parts. This is for sewing purpose only. It will take that if you are trimming one side, the material will take place in opposite side, other sides. It is also necessary you have to trim all at once. You can do it separately for circular packet, separately go for hexagonal packets, separately we can go for these packets. And now I am going to explain how to do trimming, how to do trim boundaries in machining process. In this case, you can trim any particular areas or in half of the portions and any portions as you required. Go to sketch command. Make it take line commands or any commands. You go to finish sketch. Then you see I need this particular ASN to be trimmed. So either you can create curve or you have to create by using extract options. Go to menu, insert, in derive, in this extract legacy command is there. You have to extract this command, highlight this curve. Same like this. Here also I required. I required this curve also. Okay. Now we will trim it as per your requirements. Go to trim commands. This curve I required. So then it will ask which you want to keep it. You want to keep it here. Go to keep it and apply. Here also. You want to keep this curve. You have to apply. Here. You have to keep this curve. Apply. Here. You want to keep this curve, keep, then apply. So now we have selected these areas. Here also we will go like this. Which area you want to keep it, apply. And here this curve, which you want to keep it, this you want to discard, you can go for discard and apply. On this lengthy line, this you want to keep this line, go to keep, apply. Here also, or which you want to keep it, I want to keep this one, apply. Now you selected or created by using these options. Now I will go for machining. Go to manufacturing. Go to geometrical view. Then go for MCS mill. You have to go for editing. Specify MCS. I already explained that MCS means machine coordinate system. You have to keep anywhere, any places, here or here or here, or center or corner. I made it center. Then shape clearance plane means the tool will come from spindle and it will maintain the distance of 10 mm above the workpiece. Then go to workpiece, go to edit commands, we have to specify the part. This is my part, and we have to specify blank. Go to bounding block, we have to specify this is my blank. Then this is, you can select any one steel. The harness is having 100 to 150 free machining properties. For reference purpose, you can make it mild steel. Then go to OK. Now we have completed machine coordinate system, mill geometry and workpiece. Now we will go for create operations. Go to contour, go to cavity operations, We have to make it programs. Tool we will select it. MCS we will go for workpiece. Method we will go for finishing. My intention is to explain trim boundaries. This specific cut area. These three areas I have to cut. For here, take tool. We can take N mill. N mill 10 mm. We have to enter 10 mm. My length of the tool is 75 mm and flute length is 55 mm. We can go for tool number 1. Here that method is mill finish method and I am not giving any stock allowance for future. We go to complete machining. Cut pattern method. There are so many patterns are available. Follow part, follow periphery, profile, jig, zigzag, jig with contour. Just I am taking follow part. Percent of flat diameter 50. After completion of one cut, it will take crosswise of 50%. If I am taking 10 mm means 5 mm it will go. The depth of cut is constant. Each and if I am giving 1 mm, each and every time it will take 1 mm cut. Cutting parameters you can also check it. Stop again 0 steady. Whether you want to go for up milling or down milling. Now it is down milling. Conventional means up milling. You can select any one as you like. Non-cutting. Here how to engage the cutter. We can engage the cutter by using helical width or ramp on shape or plunge. Normally we will use helical or ramp on shape to avoid damage of the cutter. How to retract. After completion of workpiece machining, the tool will come back. Cutting feeds and feeds. Here surface feed we have to put it. We have taken workpiece material mild steel and tool materials HSS, so that you might be putting 25 to 30 meter per minute. I am putting 30 meter per minute. Calculate feeds and feeds. The feed per tooth is 0.13. The spindle RPM is 955. We have to optimize feed rate, then go for working. Now we have completed all those things. Then we will go for generate the part. Now it gets generated. We will save it and we will go for verification by using 3D dynamic. This is using level cut options. I already explained that what is level cut. It will maintain the depth each and every packets. 1 mm, then go for 1 mm, then go for 1 mm, then again it will take 2 then 2, then 2. Means each and every time it is maintaining the level or balancing. And other option you might be doing that depth first. If I will use for depth first, then first it will complete one packet. After completion of one packet only, it will go to another packets. I will show. I will make it a little faster. This is level first method. Here we go to edit and we will go for cutting parameters. Here cut order, I go to change it depth first. Means it will complete that first packet. After completion only it will go to second and third. See, first it will complete. We will make it faster. Our main focus is in this session, on this particular session, how to trim the machining as per your requirements. Then I will go it edit. Here part is same, blank is same, cut area is same. Here I will create one tool for 1 mm for showing purpose. 1 mm. Total length is having this one, and it might be having 10 mm width length. Go to tool number 1, same tool. Here I will finish. I am using follow part. Here I am reducing that tool field. Here I am using 0.2. These are the things you can change it. That main thing is that you have to select cut area and you have to select trim boundaries. How to specify trim boundaries? Trim boundaries, go to curves. You have to select this curve. If it's in inside, it will take material outside. Then go to add new set. Here also you have to do it. Then go to another new set. Then you go to complete. Then we will go for generate. We will save it. We will go for verification. And you can change that cutters. You can go for 1 mm cutter for showing purpose. It might be having 20 mm total length. maybe 10 mm flute length. The maximum distance you can go for point. For sewing purpose only, I am taking very less diameter of cutters and depth of cut may be very less. Here we are explaining that how to trim boundaries. That is important things. If you are keep this side, it will go to outside. Now you want to trim inside, then I will explain how to change it. Whether you are going to trim inside or outside, that is the main point. If you are putting inside, the cutter will take place in outside. If you are putting outside, the cutter will take inside. Now, its diameter 1 mm and depth of cut is 0.2, so that it takes time. It will be visible and it will be understandable for you. Then we will verify. First we will save it, go to toolbar and verify. Now we will make it a little bit faster. Now you may have some clarification. Now you look at this area is to be trimmed. This area and this area is to be trimmed. This area we will keep it. So go to editing options. Here go to trim boundaries. Here first here go to outside. Then second here go to outside. Third here go to outside. Then OK. Then can go for generate the path. See the difference. It is depend upon how you are selecting which, whether you will select inside or outside. It is very important. It takes some time. Normally if you are taking 1 mm end mill, you should not give more than 0.1, 0.2 depth of cut, otherwise the cutter will be broken. For sewing and explanation and industrial purpose only, I am taking this cutting parameters and cutting tools. Now we can verify the toolbar, make it a little bit faster. See the difference if you are selecting inside or selecting outside, what will happen. I hope that you can also watch and you can also understand our difference between inside and outside and how to trim machining by using boundary methods. Now we can go a little bit faster, otherwise it will take time. Now remaining everything is same. Go to post processor. Here we can go for mill 3 axis or the post processor which we are giving decal mogo Simeric 840D inch 840D metric. You can select anyone. Defaultly I selected mill 3 axis. Then where you want to keep file here. The next one that important is your unit. If you want the output unit inch or metric, if you are metric, you go to select metric, then go to OK. Now it is converted for your CNC milling G code M code. Defaultly we have taken Fanuc post processor. Now it is converting. Takes a little bit time. Since we have given depth of cut is 0.2 mm, so it has to calculate all cutting speed, feed, depth of cut. Now, so far I explained how to trim boundaries or how to trim your machining. Then we will close. I hope that I explained very well, and you have to do some practices. You might be knowing that G40 cutter release compensation nil or cancel, G17 plane XY and Z will be the vertical direction of tool, G90 absolute coordinate system, G71 the reading will come in metric, G91 incremental coordinate system, G20 reference, T01 tool number 1, M06 spindle change, S955 spindle rotation or RPM of the cutter, M03 clockwise spindle clockwise, G43 cutter length compensation 10 mm. Here you can put it 50 or 40 up to your machine. You have to enter this height in your machine register. Then it will again cross or travel Z3, that cutting action will be taken.
Thank you for watching. Please like, share and subscribe. And if you have any doubt, kindly let me know in comment section.